Alright, welcome back to Explain 3 for 18.1, where we'll be going over modeling with sine and cosine functions with regards to word problems. So in example 3, they want us to graph each function. They want us to then find its frequency. And then they want us to tell us what the frequency, amplitude, and period represent in the context of the problem. The first problem we're given is involving physics. And they say use a sine function. So keep that in mind. That's going to help us to figure out what our graph's going to look like. Sine function to graph a sound wave. So whenever you listen to like music, right, because everyone likes music, those are actually sound waves that are kind of sent out that your ear kind of receives. So it's a sound wave, so it'll look kind of wavy, just so you know. With a period of 0.004 second and an amplitude of 4 pascals. So the first thing they ask to do, just like in the directions, is to graph that function. So remember, sine means we're going to have a y-intercept that starts at 0. So my first point I'm going to put is at 0 because it's a sine function. And they at least give us that, right? The next thing we're going to do is we see that there's a period of 0.004. Okay, so this is my seconds, right, for time. I know the graph looks a little wonky, but you notice how, just like I drew here, it's going to start in a place, and it's going to go up, and it's going to go down, and back to its starting position in about 0.004 seconds. So I'm going to draw a dot at 0.004. So that means it's going to go up, and you're like, how high does it go up, right? So remember, our amplitude is about 4 pascals. So remember, amplitude, just a reminder, amplitude is going to be how high a wave goes and how low a wave goes. I probably made that uneven, but you get the idea. High, low, right? So that means from here it's going to go high about up to 4 and come back down. Now you're probably wondering, well, where's that x-intercept going to be? Well, what's halfway between 0 and 0.004? Give you a hint. It's right there in the middle. 0.002. So let's go high and then back down low. And it's going to go as low as about -4. You're probably wondering, why do you know it's 4 and -4? Because they told me the amplitude's about 4 pascals. And I'll come back up. And that was so much fun. Let's do it again. So it'll go back up and down. And it's a sketch, so please don't judge me on my graph. Just like I won't be judging you on yours. Okay, goes up 4 and -4. Okay, so there's my graph. Did the first part. Yay. Okay, now we're going to find the frequency. Now just so you know, frequency can be found by dividing 1 divided by your period. So that's 1 divided by 0.004 seconds. Alright, so work that out on your calculator. Take a second. And that would be about 250. So it says, now let's fill out some sentence starters, because they said not only graph it, find its frequency. We did the first two things. That's awesome. We graphed it, found its frequency, but now we got to tell what do these values mean in the context of this problem. Alright, so here's some sentence starters to help us out. The frequency represents the cycle of a sound wave every second. Okay, so let's fill those in. So sound wave every second. Next, the amplitude represents the, well, the first thing we hit, was that a maximum or a minimum? That was a maximum, right? So the maximum change in air pressure. And the period represents the amount of, well, what are we measuring on the x-axis? Well, we're measuring seconds, right? And seconds is in the form of, is that measuring distance? Time? What do you think it's measuring? Time. The time it takes for a sound wave to repeat. Okay, so we did the first one. Let's go ahead and go on to part B. And it's another physics problem. This time, we're going to do the same things. We're still going to graph it. Okay, just so you know. We're still going to tell what the frequency is and kind of give what our sentence starters would be, so kind of give us a context. Alright, so it says use a cosine function. So a cosine function. So just so you remember, a cosine function will start on the y-axis at an actual number. So it's not going to start not at 0, just so you know. It's going to start at an actual number. You're like, I wonder what that number is going to be. Me too. Let's figure it out. So just know that we're going to start on the y-axis, not at 0. So cosine function to graph a sound wave of a period of about 0.010 seconds at an amplitude of 3 pascals. Remember, amplitude is how high it goes and how low it goes and how it comes right back up. So on our, just kind of doing a sketch right now. That's too high, but whatever. So it's going to go as high as 3 and negative 3. That kind of gives us an indication of where our y-axis or our y-intercept is going to be at. It's going to have a y-intercept of 3 because our amplitude was 3. And notice how it goes down and back up in about 0.010 seconds. So I'm going to draw another point here. So it's going to go down and it's going to reach a level of negative 3. Just so you can kind of know. Oh, my line isn't that straight as I'd want it to be, but there we go. Okay. Just so you know, those lines are just to kind of keep, you know, within that range. It's going to go up to 3 and down to 3, up to 3, down to 3. We can erase those later once I actually have a sketch. Alright, so it's going to go down and back up in about 0.010 seconds. Well, let's figure out what's the halfway point between 0 and 0.010. What's halfway? Hint, it's right there. That's the halfway point. So it's going to go down. Yep. It's going to go down. And it's going to hit about negative 3 at that point, and it's going to come right back up. Okay, and I know it looks kind of like a V, but we can make it kind of curvy on your graph. And it's going to do that again. Again, I'm drawing these points just so I can kind of keep it level. And what's halfway between 0.010 and 0.020? It's right there again. So we're going to go down, down to negative 3, because that's the amplitude, and back up. Oh, it looks like kind of like a W. That's kind of cool. And it's going to keep doing that over and over again. So we did our graph. Yay. Now we're going to find our frequency. So 1 divided by our period. They told us our period is about 0.010 seconds. So I'm going to put that here, 0.010. And I like that it puts it in hertz, which is nice. So we are studying sound waves here. Alright, go ahead and take a minute to work that out. And you should have gotten about 100. Okay, so the next thing we're going to do is just kind of give context. So the frequency represents the number of cycles of a sound wave every, well, are we measuring in minutes, seconds, days, weeks? What are we measuring time in? seconds, right? You're like, how do you know that? Because they tell it right here in the problem, seconds. All right, the amplitude represents the maximum change in, and on the last one, we saw that that was a maximum change in air pressure. Same thing, air pressure. And the period represents the amount of time it takes for a sound wave to end or to repeat. So let's look on the last one. Sound wave to repeat, because a sound wave doesn't really end unless you turn off the music, I guess, but it kind of continually repeats, as we saw in this last graph, and as you can see, it kind of continually repeats for this graph. Okay, and just like I said, you can erase those lines. You don't have to keep them. In fact, right now I'll go ahead and erase that and that so it looks more like a graph. Awesome. Just like it says here on the screen and at the bottom of your page, stop here and do the problems in your packet. On the next video, we'll be going over your homework. Okay? See you on the next video.